Hello students! So in this video here we're going to be looking at factoring by grouping, or factoring quadratic trinomials by grouping. What's important for us to mention first off is exactly what we mean when we say grouping. So when we say grouping, we're referring to using parentheses. And I don't know how many of you remember the associative property when you're dealing with different expressions. But with the associative property, you can kind of switch the positions of parentheses and kind of work with different types of groupings with parentheses. But anyway, that's what we mean when we say group. Okay, grouping. We're talking about certain parentheses, but we'll look at all of that. All right. So first, we're just going to look at just how to factor by grouping in general, even if it's not a quadratic expression, because factoring by grouping works with other types of polynomials, not just quadratic. So we're just going to look at factoring by grouping first. Okay, so let's say that we were looking at this example here. Notice how there are 4 terms, and so before we actually look at factoring by grouping here, let's just kind of talk about how do we even know that we can factor by grouping. Like, what's the right setup? What's the right form for us to even know that this expression can be factored by grouping? And so, first off, the fact that it has 4 terms, that's one criteria that we need to have in order to factor by grouping. So, when we're trying to determine whether an expression can be factored by grouping, one of the first things that lets us know, and it's not the only thing, but that expression must be written with 4 terms. So if it's not written with 4 terms, more than likely it can't be factored by grouping. Now, there are some expressions where we can actually rewrite it, or write an equivalent form of it where it is written with 4 terms. But again, we'll look at that a little bit later. But again, so it must be written with 4 terms in order for you to factor by grouping. So with that first criteria, it must be written with 4 terms. All right, we've got a match for that. Okay, that first criteria for this one is met. It is definitely written with 4 terms. Let's check out and let's see the second thing that must be true. Or the second thing that kind of lets us determine whether or not an expression can be factored by grouping. It can only be factored by grouping if the ratio of the first 2 coefficients are equivalent to the ratio of the last 2 coefficients. So again, and for those who may be kind of wondering, okay, I slightly remember hearing the word ratio, and Mr. Starkey, but you're going to have to remind me, what's a ratio again? And what do you mean by the ratio of the first 2 coefficients? Well, I'm glad you asked. So, again, the first 2 coefficients are 1 and -3, right? So that coefficient there is 1. This coefficient is -3. The ratio there would be 1 to -3. Okay, do you guys sort of kind of remember ratios? Again, ratios can be written like that, 1 to -3. Ratio can also be written as a fraction. But again, I'm not going to write it as a fraction. Well, I'm not going to say that just yet. I probably will write it as a fraction in just a second. All right, so that ratio must be equivalent to the ratio of these last two terms. So again, the ratio of the first two terms is 1 to 3, and the ratio of these last two terms is 6 to negative 18. Now, if you're unsure about whether or not this is really equivalent to that first ratio, here's what we can do. Remember, we said that ratios can also be written as fractions, right? So let's write these two ratios as fractions. So if we write this as a fraction, one or negative 1/3. If we write it as a fraction, are these two fractions equivalent to each other? In other words, do these two have the same value? Like if you were to write the ratios as fractions. For some people who are still wondering, okay, Mr. Starkey, I still don't know. I don't know, Mr. Starkey. Okay, that's fine. You ain't got to know. It's okay. But you will, by the time we get through with you, you will know. Alright, so again, guys, if you're unsure about, okay, well, do they have the same value? Okay, you got a calculator, right? You can figure out what the value is of negative 1 divided by 3, right? If you don't know that that's 1/3 or 0.3 repeating, right? That's 1/3 or negative 0.33 or negative 0.3 repeating. And this one, when you divide negative 6 by 18, gives you the same exact value. So, since technically these two ratios, or written as fractions, they do have the same value here, they are equivalent to each other. The ratio of the first two terms is the same as the ratio for these last two terms. So since that is the case, then this second criteria has been met. All right, and we're talking about determining whether or not you can actually factor by grouping. All right, so that criteria is met. Okay, guys, just a quick reminder about ratios. Remember that like for instance, for a ratio like this first one, 1 to 3. So if something has a ratio of 1 to 3, that means that for every one of these things, there are 3 of these. Okay, so for every one of these, there are 3 of those. In other words, this second one is 3 times greater than that first one is. Okay, so in other words, 3 is 3 times greater than 1, and 18 is also 3 times greater than 6. Okay, all right, and yeah, so again, folks, this expression can be factored by grouping because it meets the 2 criteria. Again, it has 4 terms, or it's written with 4 terms, and the ratio of the first 2 terms matches and is equivalent to the ratio of the last 2 terms. So again, we can factor by grouping. Let's look at what exactly the process of factoring by grouping looks like. So when we are looking at how do we factor by grouping, the first thing that we want to do is group our terms. In other words, we want to group the first 2 terms together and the last 2 terms together using parentheses. Okay, so we have our first 2 terms grouped together and our last 2 terms grouped together using the parentheses. Next, the next thing that you want to do when we are factoring by grouping is, so we see these two groups. We see this first group here, we see the second group. What we want to do with each group is we want to factor out the GCF from each of these groups. So we factor out the GCF from this first group, and we want to factor out the GCF, or greatest common factor, from this second group. So when we're looking here for the GCF from both groups, when we look at this first group on the left, and again, I'm not gonna write it out like this time, just to save space. But again, remember I had mentioned that you can write out the variables as repeated multiplication. So here you have 4 x's, x, 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 x. Okay, 1, 2, 3, 4. 4 x's. And here you have 3 x's. The coefficient for this first part is 1. Right? So the GCF there is 1. Okay. The greatest common factor between 3 and 1 is 1, right? And then how many x's do they have in common? They have 3 x's in common. And like I said, if you need to actually write it out like we did in one of the previous videos with factoring out GCFs, then feel free to write out, you know, x 4 times, x 3 times, and for you to see how many common factors there are. All right. So the GCF from that first group is 1x to the 3rd power. The GCF from this second group, okay, so for these two numbers, 6 and negative 18, the GCF there would be 6. 6 would be the greatest common factor between those two numbers. And since both numbers do not have variables, then we cannot take out any of the variables for this group. We can't take out x because both terms do not have an x in common. All right, so we've got our GCFs, and we need to factor out those GCFs. So when we factor that out, it's going to look like this: 1x to the 3rd times, okay, and we'll write what's left over there, and then this will be plus 6 times, and we'll write what's left over there. All right. So when we look at what's left over for this first one, so I mentioned in one of the previous videos with factoring by grouping, with factoring out GCFs, that I might show you the way that the Khan Academy video shows you this. All right, so if we were looking at it like this, the original terms were x to the 4th and negative 3x cubed, right? So that's how the original thing looked: x to the 4th and negative 3x cubed. So if we kind of do it sort of like backwards, and think about if we took out 1x to the 3rd. Think about it. All right, so if we take out 3 x's there, how many x's are left? Just 1 x left over there, right? All right, and then for this one here, the same thing. For the negative 3x cubed, if we take out 3 x's, there will not be any x's left there. but they'll just be a negative 3. In other words, what is it that gets multiplied? What is it that gets multiplied by 1x to the third? That will give us x to the fourth. So the only thing that we can multiply by 1x to the third to get x to the fourth is x, right? So that means that x goes there, and the only thing that we multiply times 1x to the third to get negative 3x to the third is negative 3. So that's what's left over here. All right, if we do the same thing for this one, okay. So the original there was 6x minus 18, and if we factor out a 6 times what gives you 6x? Well, 6 times x gives me 6x. All right, and then 6 times what number gives you negative 18? 6 times negative 3 gives me negative 18. So again, we see here that we have x minus 3 left over. All right, now here's what's important for you to realize here. When we did this and we factored out those GCFs, do you notice that these two things that were left over are the same? Did you notice that? That this part that was left over was x minus 3, and this part that was left over was x minus 3? Okay? And the reason why that is the same is really because the ratio of those coefficients was the same. Okay? The ratio of those coefficients was the same. And so because the ratio of those coefficients was the same, and again, that was one of the criteria that needed to be met for us to factor by grouping, because that ratio is always going to be the same, when we factor out the GCFs, guys, we are always going to get, or we should always get the same factor, or the same thing that's left over there. So again, if you've got the same factor that shows up, that lets us know that we're on the right track. In this case, that same factor that we've got here is x minus 3. Once you've got that, what you need to do is you need to group together the two GCFs. Group together, or group the two GCFs together as one factor, and then use the same factor as the other factor. All right, and so again, you're going to use the same factor, that x minus 3, as one of the factors, and you're going to use these two GCFs, the x to the third and the plus 6. You're going to group those two together as the second factor. So when we write out that last step, it's going to be written like this, in this form. Again, the GCFs times that same factor. So again, if I had to write that out, the GCFs, when we put those two together as one group, when we group those two GCFs together, it's going to look like x cubed plus 6. And then, of course, that same factor was none other than x minus 3. Right? So this is, or these are our two factors here. And this is the answer. Okay? Okay, so if you kind of look at this last little thing that we have written as the answer, the x cubed plus 6 times x minus 3, it sort of looks like And then if you guys kind of look at right above that, where you see the same factor written out twice like that, that expression where you have the same factor written out twice, it sort of kind of looks like extended distribution, right? Where you got the x minus 3 being multiplied by both of those parts. So again, you see this green part here. You got that x to the third power that's being multiplied times the x minus 3. And then you got this other green part, the 6, that's also being multiplied times the x minus 3. So again, in the end, it will look like what you see here inside this box. X to the third plus 6 times x minus 3. But again, I just kind of wanted to kind of bring back to your memory of what that sort of looks like, where you see the green and the blue underlined there. Again, that does sort of remind me of extended distribution. So guys, that is it for this first part. We've talked about again what it means when it says grouping, what we're referring to when we're talking about grouping. We've talked about how to determine whether or not you can factor by grouping, and we kind of went through the steps of factoring by grouping. And again, we had mentioned that you must have 4 terms. In the next video, in part 2, we're going to look at how to factor quadratic trinomials by grouping, and so we're going to look at how to factor quadratic trinomials by grouping. All right, stick around for part 2, guys.